Projectile Motion by Nicholas Capsalis. The best way to learn about projectile motion is through a real-life example. What I did was I took a baseball and I threw it as far as I could. I had someone record with a stopwatch how long it took for the ball to leave my hand right there to the point where it landed. I also, after doing that, I took out a tape measure of 100 feet and I measured from my X displacement from home plate to exactly where the ball landed. The time was 3.43 seconds, the X displacement was 200 feet, and the ball was thrown at approximately a 45-degree angle. Now that we have this information, we can solve for a whole bunch of different things. But before we can, the most important thing that we need to do is solve for the velocity. Velocity is equal to distance over time. Since the ball went 200 feet in 3.43 seconds, you'd put 200 divided by 3.43 to equal the velocity. The velocity is equal to 58.3. Now we write down the knowns and unknowns. Right now what we know is that the time is 3.43, the x displacement is 200, the velocity initial we know is 58.3, but in the x direction you need to put cosine 45 because that's the angle that you're multiplying the velocity by. Velocity initial in the y direction would be 58.3 sine 45, and that's so you have the angle incorporated. The x acceleration is 0 because the velocity is constant throughout this entire equation, and the y acceleration is 9.8 or negative 9.8. Negative would only be used just to tell the direction that it's going in. So if it's going in a downward direction, you'd have the negative sign in front of the 9.8. Right now our unknowns are our y displacement, our x velocity final, and our y velocity final. Using the knowns that we have, we can plug them into equations and we can solve for all three of these. The first one we're going to solve for is the velocity final in the y direction. This is actually really easy because the v final in the y direction is just 0. Because it's like a parabola, projectile motion, both sides offset. So for the second half, you'd be going in downward direction, which would be a negative acceleration. And for the first half, you'd be going into a positive acceleration. And these would both cancel out. When it's at the max height, that's when it would be at a total stop, no acceleration whatsoever in the y direction, and that would be at 0. The next thing we're going to solve for is the displacement in the y value. We have velocity final y squared equals viy squared plus acceleration of y d. Now, since we already found the velocity final in the y direction, which was 0, you plug that in. You plug in all the other variables, and you have the equation written 0 squared equals 58 times the sine of 45 squared plus negative 9.8 d2. Now, all of you are probably wondering why is the 2 there. That's because we're halfway through the marking point. So, since it's half, you got to multiply by 2 since they're directly proportional. After you solve all the math and all that, you find out that the y displacement is 124.27. That's how high the ball hit halfway through. So that's the farthest point in the air that the ball got. So it was 124.27 feet in the air. The final thing we needed to know was what is the velocity of x and the final velocity of x. There's one important thing you need to know, and that's 3 words. Velocity is constant. The velocity initial at the beginning is also the velocity at the final because there is no acceleration happening. Because of this, the velocity final is equal to the velocity initial, which is equal to 58.3. Thank you for watching this projectile motion demonstration, and I really hope this helped you out in your physics class.